Greetings, dear learners. In this week, we shall learn the metallic poisons. Many metallic elements in the trace quantities like iron, cobalt, copper, manganese, molybdenum, zinc are essential for various biological processes. Some of them activate enzymes, others facilitate exchange and utilization of oxygen and carbon dioxide, while most of these trace elements are acquired in adequate quantities through food, excessive exposure in nutritional, occupational, or environmental way, that can lead to progressive accumulation and toxicity resulting in serious consequences. Often these metal poisoning are referred to as heavy metal poisoning. A heavy metal is a member of loosely defined subset of elements that exhibit metallic properties. It includes mainly the transition metals, some metalloids, lanthanides, and actinides. Various definitions have been proposed for the term heavy metals, some based on density, some on atomic number or atomic weight, and some on chemical properties or toxicity. The term heavy metal is, however, a misnomer since it can refer to elements lighter than carbon. Various definitions have been proposed for the term heavy metals, some based on density, some on atomic number or atomic weight, and some on chemical properties and toxicity. One of the definitions says that the metals heavier than the carbon are the heavy metals. So, according to that definition, heavy metal is a misnomer since it can refer to elements lighter than carbon while excluding some of the heaviest metals. A more acceptable term would be toxic metal, though in general perception, a more acceptable alternative term would be toxic metal. So it shall be the toxic metal poisoning rather than heavy metal poisoning. Though the general perception is that heavy metal poisoning is uncommon, the actual fact is just the opposite. Heavy metal poisoning, acute as well as chronic, is a major cause of morbidity and mortality all over the world, and India is no exception. Major toxic metals are arsenic, lead, mercury, copper, iron, cadmium, and thallium. We will be understanding poisoning due to each of them one by one. So let's start with the arsenic, also called king of poisons. Arsenic was used as a therapeutic agent by the ancient Greeks and Romans who considered it as a kind of sulfur. Since arsenious trioxide, also locally called as Sankhya, shares many properties as an ideal homicidal poison, that it is tasteless, odorless, easily available as rodenticide, required in small quantities to kill. Symptoms resembles that of natural disease cholera poisoning. No test was available to detect it at that time, so it was called as king of poisons. Also the poison of kings because it was frequently used to kill the kings. Another epithet was poudre de succession, a French word that means for inheritance powder, because youngsters could easily kill their rich uncles to inherit their money. Women easily killed their husbands by mixing it in their food. With the advent of mass test in 1836, it fell out of favor as an ideal homicidal poison. Then the poisoning of Napoleon Bonaparte or Napoleon, who was killed by the Britishers using arsenic. Napoleon was one of the five brothers born in Corsica and ruled as Emperor of France from 1804 to 1815. His siblings included Jerome Bonaparte, who was the King of Westphalia from 1807 to 1813, Joseph Bonaparte, who was the King of Naples from 1806 to 1808, and of Spain from 1808 to 13, Louis Bonaparte, who was the King of Holland from 1806 to 1810, and Lucien Bonaparte, who was a French government official. So all his family members were the royal family members. But it is the Napoleon who had always captured the attention of historians because of his confident and daring exploits, and perhaps also because of his tragic demise. The legendary Battle of Waterloo in 1815 was a concerted effort on parts of England, Russia, Persia, and Austria to defeat Napoleon, which they did, and the vanquished son of the France was then exiled to a very remote island at St. Helena, a British colony in Atlantica, where 6 years later he died a mysterious death. Some of the Napoleon's companions documented the detail of some of the Napoleon's companions documented the details of his sickness until the very end on 5th May 1821 in their respective diaries, which were later published. The symptoms described by his personal physician, Dr. Anto Marchi, was particularly significant, as they are strongly suggestive of chronic arsenic poisoning. Immediately after the death of Napoleon, his valet Novraz cut some hairs from the scalp and gave it to Dr. Antomarchi, which were procured by Ben Vedder, a Napoleonic scholar, in 1960, who submitted the sample to the Harwell Nuclear Research Laboratory in London for analysis. There, the neutron activation analysis was done, which revealed the fluctuating levels of arsenic throughout the length of hairs, ranging from 4.4 to 23 parts per million. Another sample of Napoleon's hair obtained from his scalp while he was still alive on October 16, 1816 was submitted to the Toxicology Crime Laboratory of FBI of the US. This specimen, comprising just two strands, revealed 16.8 ppm of the arsenic in one and 33.3 ppm of arsenic in another, as demonstrated by graphite furnace atomic absorption spectroscopy. The Heavy Metal Laboratory of Mayo Clinic, Minnesota, USA states that 1 ppm of arsenic in air is the baseline level, while any level more than 10 ppm is indicative of significant toxicity. While arsenic was used in form of deliberately adulterated wine to chronically weaken Napoleon by his assassins, the most prominent of whom was his aide and principal wine steward, Count Monthlon. The actual killing was accomplished with the help of tartar emetic, that is potassium antimony tartrate, calomel, that is mercurius chloride, and orgeat, an orange drink flavored with vial of bitter almonds containing hydrocyanic acid. Tartar emetics, by inducing vomiting, causes the stomach to become empty, which facilitates the mixing of mercurius chloride and hydrocyanic acid to produce mercuric cyanide. Thus, the terminal event in Napoleon's death was cyanide poisoning. It is documented that after consuming the orgeat administered by his assassins, Napoleon fell unconscious and died after some hours without ever again recovering consciousness. Immediately after the Napoleon's death, a commemorative sketch was made with all his companions by his deathbed, all of whom signed the drawing except significantly for the Count Montholon. So, in the whole story, the Count Montholon was the actual suspect. So, in whole story, Count Montholon was actual suspect, and behind that the Britishers were involved. In this way, Napoleon's death was planned. Then in India, arsenic is at present freely prescribed by homeopathy and Ayurvedic practitioners. Arsenic is basically a metalloid, that is, it is an element which resembles a metal in some respects and is by itself not very toxic. Arsenic is a metalloid, that is, it is an element which resembles a metal in some respects and is by itself not very toxic. as the metalloid arsenic is insoluble in water and is not absorbed from the alimentary canal. However, almost all the salts are toxic to varying degree. When it is heated, it volatilizes, combines with the oxygen and forms arsenic trioxide, which is poisonous. Arsenic is silver gray, brittle crystalline and metallic looking element. It can exist in three allotropic forms: yellow, that is alpha, black, beta, and gray is the gamma. It is rarely found in its isolated elemental form. More commonly, it is present in mineral species, in alloys, or as an oxide or other compound form. The amorphous metalloid form alpha arsenic will darken to the black beta arsenic and form arsenic trioxide in moist air. When arsenic vapor is cooled, suddenly a yellow type of arsenic which has no metallic properties is formed. This table shows the physical properties and uses of arsenic and their different compounds. You can see the different compounds of the arsenic. That includes the elemental arsenic, arsine, trimethyl arsine, arsenic trioxide, arsenic trichloride, sodium arsenite, arsenic pentoxide, lead arsenate, sulfides of arsenic, copper arsenate, copper acetoarsenite, organic arsenical that includes carbarsone, triparasamide, glycobirsol, merasoprolol, and others. It is a synonymous name for these different variants of the arsenic. This is the list of their physical properties. The measure of the physical properties are common, that is, it is shiny, grey, brittle, metallic looking substance, colorless gas with garlic odor, this arsine gas. Then the trimethyl arsine is colorless gas. Arsenic trioxide is white powder dissolved slowly in water to form the arsenous acid. Arsenic trichloride is yellow, oily liquid, white or greyish color, then white powder, heavy white powder, red powder, sulfides of the arsenic, greenish powder, copper arsenite, copper acetoarsenite is also greenish powder. Then their usage is given in this part. Elemental arsenic is used in alloys. Arsine gas is used for lead plating, soldering, galvanizing, and in electronic components. Trimethyl arsine is present in the sewage. Then arsenic trioxide is used in manufacture of glass, insecticide, rodenticide, previously used in medicines for treating fever, that is used in the Fowler's solution, and today re-emerging as an effective agent for the treatment of promyelocytic leukemia. Then arsenic trichloride is used in pottery. Then sodium arsenite is used as insecticide, wood preservative, and veterinary medicines. Arsenic pentoxide is used to manufacture of the colored glass, insecticide, wood preservatives. Lead arsenate is used as insecticide. Sulfides of arsenic is used as depilatory, that is for the removal of hair and the color pigment. Then the copper arsenite is used as coloring agent for toys and the wallpaper. Copper acetoarsenite is an insecticide. Then the organic arsenical, under that milarsoprol, the arsenous oxide derivative of an organic arsenical, is used to treat the meningoencephalitis stage of West African and East African trypanosomiasis. Then the mechanism of action of the arsenic poisons. Arsenic is absorbed through all the portals of entry, whether it is orally, nasal or cutaneous routes. The trivalent arsenic has the great affinity for the sulfhydryl group. It binds to the sulfhydryl group of the mitochondrial membrane and damages them, resulting in release of cytochrome C that causes activation of caspase enzyme, which causes the apoptosis. Arsenic induces apoptosis of the cells. Then another mechanism is it down-regulates the gene expression of BCL2, a pro-survival protein that protects against the apoptosis. Then it inhibits the pyruvate dehydrogenase complex, leading to disruption of oxidative phosphorylation. Then it inhibits the glutathione synthetase enzyme, glutathione reductase, and the glucose 6 phosphatase dehydrogenase that results in the decrease in the glutathione, which is required to protect the RBCs from the oxidative damage and to maintain the hemoglobin in ferrous stage and scavenge water and other organic peroxidases. It also replaces phosphorus in the bone. So, for the confirmation of the arsenic toxicity, sample from the bone may be taken that may be analyzed for the arsenic compounds. Then coming to the toxicokinetics of the arsenic, it is well absorbed from the GIT as pentavalent arsenic. Arsine gas is well absorbed from the respiratory tract and arsenite from the skin. Upon absorption, it is bound to the protein portion of hemoglobin and alpha globulins. Once absorbed, arsenic is quickly distributed to all the organs and tissues. In early stages, arsenic is found maximally in the liver and followed by kidney and spleen. It doesn't cross the blood-brain barrier. In chronic poisoning found in muscles for the several days and in keratin containing tissues like skin, hair, nails for several years. It can appear in hair and nails within hours of ingestion. It attaches itself to sulfhydryl group which are abundant in keratin. It gets incorporated in bone by replacing the phosphorus, especially long bones like femur. It gets incorporated in the bones, replacing the phosphorus, especially long bones like femur. So, there it can be used for the analytical purpose. Then, for elimination from the body, it is mainly eliminated by the kidney as methylated arsenic. It is found in urine within hours of ingestion. Then onwards, elimination is continuous for about 10 to 12 days. In acute poisoning, 24-hour excretion shall be noted. If it is more than 100 mg, then it is suggestive of acute arsenic poisoning. Then it can be eliminated in the breast milk also. Then other routes of elimination are bile, feces, sweat and other secretions. It also has an intrahepatic circulation. We already discussed that the poisons that are having intrahepatic circulation, even when it is given through the parenteral route, it will be detected in the stomach and intestines.